So we propose here a sensitivity analysis of an option premium to the evolution of the spot price of the underlying asset and to the time to expiration of the option. According to Black Scholes, the call premium is based on 5 parameters. S, the spot price of the underlying asset. E, the strike price of the option. Tau, the time to expiration of the option, which is necessarily expressed in years. Sigma, the volatility of the underlying asset, and R, the risk-free rate. Among these 5 parameters, 4 ones are likely to change between the valuation date, today, and the expiration date. Spot price of the underlying asset, the time to expiration, the volatility, and the risk-free rate. But among these 4 parameters, 2 ones are more likely to change. First of all, if we speak about the volatility of the underlying asset, it means that the spot price of the underlying asset is very likely to change. Moreover, we are sure that the time to expiration of the option will change between valuation date and expiration date, because every day, in terms of life of the option, 1 day is lost, which means that every day part of the time premium is lost. This is why we focus on the sensitivity of the call premium, then of the put premium, on the spot price of the underlying asset, and on the time to expiration. We have here a very simple Black Scholes pricing model. We have here the call premium, which is based on the customary Black Scholes formula, and then based on the call-put parity, the put premium. In order to show the sensitivity, we have built 2 tables. In fact, no formula has been entered yet. We've only specified here for the call the various values S could take 80, 90, 100, 110, 120. We've taken into account 4 valuation dates: 2nd of April, 2nd of May, 2nd of June, and 14th of June. I mean, 1 day before expiration date. And we have the same for the put. First of all, if we want to have a sensitivity table, we need to enter a link between the table and the central case. We want to simulate the call premium, which means that we want to simulate this formula. Of course, we are going to hide this amount, and the only way to do it is whether to change the color of the font and take a white one. Then it disappears, but if I type on F2 on a PC or double click on the mouse of a Mac, I can see that the relationship still exists. Then I select the whole table, including the assumptions for S, the assumptions for the valuation date, and I go to Data, What If Analysis, Table of Data. And I'm saying to Excel that on the first line of my table, I have the spot price of the underlying asset. I have S, which is 120 in our central case. Regarding the first column of the sensitivity table, I have the valuation date, which is the 2nd of April in our central case. And then I have the various values of the call premium. First of all, we can check that the table is correct because we get in this cell corresponding to 120 for S and the 2nd of April for the valuation date, what we have in the central case. It's not the right green, but everybody has understood that the table is correct. Then we are going to prepare a graph based on that. We are going for that to select what's inside the table. We are going to insert a graph in terms of lines, and we recognize the profile of a call premium according to the valuation date. Of course, the x-axis is not correct. I mean that by default, Excel is saying that it is between 1 and 5, whereas it is between 80 and 120. So we are going to select datas, and we are going to say that for the x-axis, we want to take the amounts between 80 and 120 we have there. Now for the names of the series, the names of each curve. In blue, we have the situation on the 2nd of April. So we modify series 1 and we click on 2nd of April. Then for series number 2, we modify and replace by the 2nd of May. Series number 3, we modify and replace by 2nd of June. And for the series number 4, we modify and replace by the 14th of June. We can say that we have here the sensitivity of the call premium to S and the valuation date. We can moreover have smooth curves. Okay, for that we simply have to select what we want and say that we want to have a smooth line here. So first of all I select it and I go on the bottom here and I type on smooth line. Same here, and same for the last one. We can see it may be more obvious if we look at the table that if we take an assumption regarding the spot price of the underlying asset, for example in the middle of the table 100 euros, we can see that when we go further in time, the call's premium is decreasing. It's the same in each column, of course. If we look at a line, we can see that if the spot price of the underlying asset is increasing, mechanically the intrinsic value is increasing and therefore the call premium is increasing too. We are going to do the same for the put. So again, we have a table which has been prepared at this stage with no formula. We only have to enter here the relationship between the table which is there and what we want to simulate, namely the put premium, which is still here, even if we do not see it. It's because it's been put in white. Then I select all the table, including the assumptions. I go again to datas, what if analysis, table of data. On the first line of the table, I have the spot price of the underlying asset, which is 120 in our central case. And in the first column of the table, I have the valuation date, which is the 2nd of April 2021. And I have the various values. Again, I can see, as for the call, that if I take whatever column, when I'm going further in time, the time premium is decreasing, and therefore the premium of the option is decreasing. We can see that in the first column, in the second, and so on. Then we can, of course, prepare a graph. For that, we select what's inside the table. We go to insert a graph in terms of lines, and we recognize the curve of the put. Of course, again, we need to take the right numbers, the right values for the x-axis, I mean between 80 and 120, instead of having numbers from 1 to 5. So I select datas, and again I modify the x-axis taking these data into account. And for each curve, we need to change the assumptions, which are in fact in the table here. So again, select data, and we are going to say that for the first series of data, we modify and we take the 2nd of April. For the second one, we modify and take the 2nd of May. For the third one, we modify and take the 2nd of June. And to terminate, for the last one, we modify and take the 14th of June. And of course, we can do exactly what's been done for the call. First of all, we can put a title. We can say sensitivity of the put premium. To S and to the valuation date. We can also try to have some smooth curves. For that, I go to here, and again, I'm going to click on smooth curve here. And I can do that for each curve corresponding to what I am currently doing. So I have, in that context, the sensitivity of the put premium to the spot price of the underlying asset and to the valuation date. I will put in the comments of this video the link in order to get this Excel sheet.